Hello, this is a special case that I want to discuss with you in the area of rational functions. Now we will start with this rational function. Now, before we factor, we will find the horizontal asymptote since we need the original function to do that, and we will also find the y-intercept. Now, in this case, it's big on top. The degree in the numerator is larger than the degree in the numerator, so there is no horizontal asymptote. We find the y-intercept by substituting in 0 every place we see x. That's going to give us a y-intercept at -1. If you're not sure that you understand that, try that on paper. Now it's time to factor and find our holes. It turns out that we have a hole at x = 3. How do I know that? Because when I factored, I found a factor common to the numerator and denominator. I set that equal to 0 and I solved. Hence, we have a hole at x = 3. So now, after I factor out the hole, after we cancel out that common factor, x - 3, we end up with a linear function, f of x is equal to 2x - 1. It is in the form y is equal to mx plus b, the slope-intercept form. Now, okay, we have this linear function, f of x is equal to 2x - 1. We can find the x-intercept, and we know that's where the function is equal to 0, so we're going to set 2x - 1 equal to 0 and solve, and we end up with an x-intercept at 1, x is 1/2, y is equal to 0. We can also find the domain and range of this thing. Now, the domain is all real numbers except vertical asymptotes and holes. So we know that this function has no vertical asymptotes. How do we know? Because vertical asymptotes are found after you cancel out holes by taking any factors in the denominator and setting them equal to 0. Well, this function, 2x - 1, has no factors in the denominator after we got rid of the holes. Therefore, it has no vertical asymptotes. But we know from our previous work that it does have a hole at x = 3. So the domain then is x is equal to all real numbers except 3. Now, this is a special case scenario. In this case, we know there's a hole at 3, but we have to consider the impact of this on the range. If, in fact, x was equal to 3, our function would be equal to 5 if there was no hole. But there is a hole. That means that since x will never equal 5, or 3, y will never equal 5. So our range is y, such that y is equal to all real numbers except 5. So let me go over that again. If x was not a hole, if there was no hole, and x was equal to 3, then this function f of x would be equal to 5. But we know there is a hole. X can never be 3. Therefore, this function will never be equal to 5. That is how we derive our range. So let's recap, because we did a lot. We started with this rational function. We found the horizontal asymptote and the y-intercept, and then after factoring it, we canceled out the holes. And we ended up with this linear function, f of x is equal to 2x - 1. Now, we already determined it has a hole at x = 3. These are its x and y intercepts. it has a domain of all real numbers except 3. That's tied to the whole. And it has a range of all real numbers except 5. That's also tied to the value of the function at the whole. But there is one more thing. What if you had to graph this? Well, luckily, this is a linear function, and you know how to do that. You would start by plotting the x and y intercepts. Now, normally, if you didn't have to worry about holes, once you have 2 points, you could just take a straight edge or a ruler and connect them and have your graph. But we do have to worry about our hole at x equals 3. So what do? We know that this hole exists at x equals 3 and y is equal to 5. And so we're going to draw an open circle at 3, 5. Now I literally mean an open circle big enough for you to see and for whoever's evaluating your work to see. And then we're going to graph the rest of the line, leaving the point 3, 5 open. Something like this example. You see my line, and then it's interrupted by an open circle, and then my line continues. Something like that. Now, that's all you really need to know for this special case. This special case occurs when the only factor in the denominator happens to be a hole. If you run into that situation, then you end up having a linear function which has no horizontal asymptote, no vertical asymptote. It does have x and y intercepts, and it does have domain and range. So those are the things you would have to look at if it was just a regular linear function. And last, graphing it, you have to take into the account the whole, and you would do that simply by putting in an open circle. Well, that's the end of this special case. If you have questions, see me.